Hi, in this video we're going to talk about biosensors and technologies for connected healthcare ecosystems. So I will describe a couple of technologies that we're fairly synonymous for at ZP, which is point of care diagnostics and also wearable biosensors as well. Now, these kind of technologies, even though ZP develops them and manufactures them, our business model is a little bit different, that actually we're always the kind of technology and supplier of these technologies into other companies. So this is a kind of point of care type technology or point of need type technology. And I've also got a couple of wearable biosensors here as well. I'll just put my hand on those as well. So we've got wearable here. This is a watch that goes on the wrist and has microneedles, and the microneedles penetrate the skin, and that can be used then for measuring analytes in what's called the interstitial fluid. So at ZP we're not famous, but we're well known for both IVD, in vitro diagnostics, and also wearable biosensors as well. That's the kind of sports version of the watch. With that said, let me go forward with my with a couple of slides. So we are sort of fairly well known for this. I think we're also fairly well known for actually having quite a large portfolio of biosensors from sort of, if you think about the comprehensive metabolite panel, you know, things like glucose, lactate, sodium, potassium, oxygen, calcium, things like that. Then ZP has, you know, this sort of wide range of electrochemical biosensors. Now, when ZP first started up, we were kind of very much part of this kind of IoT of health, this Internet of Things of health. And in fact, the technology that I've got in front of me today is really a kind of IoT type technology, where we'll talk about hardware in Bluetooth communication with apps, and apps sending data to the cloud. So I will talk about IoT type things as well. So when I think about the Internet of Things, and I'm also thinking about sort of connected healthcare ecosystems, you know, we can often start with sort of a drop of blood, though I would say that, you know, for home use, then, you know, there is some good strides being made now for actually testing in saliva, for example. It's very hard to build a business model for monitoring people where it has to be a drop of blood. I understand that, you know, diabetics do it obviously because, you know, it's really important for their well-being, but people who are maybe not so chronically sick would be a bit more reluctant. But that said, you know, we make devices that are sort of Bluetooth, Wi-Fi enabled. They can work with smart devices. Smart devices can send the data to the cloud. Now, in other parallel industries, actually, you know, this workflow that I'm describing, this is something that we actually actively do. So in the place of the doctor in many of these circumstances, I'm actually looking at people's data, but this is often in industrial type applications, not medical. Now, I brought this sort of AI icon in here as well, because everyone's talking about, you know, well, we'll send our data to the cloud and let the AI, you know, crunch it and turn it into meaningful information. That's not really the theme of my talk today. I'm going to talk much more about the front end of things, the actual biosensors that are going to make all of this kind of possible. But that said, you know, when you've got AI involved, or, you know, even real people looking at information, then you can have some feedback to the patient, the end user, for example. You know, so one of the first places that will, you know, or is becoming kind of part of this connected healthcare ecosystem, I would sort of say, is people with diabetes, you know, that they're getting monitored, and the kind of technology that they have does allow itself to be connected to the internet. In fact, I've got a glucose strip technology here. I'll do a quick, you know, demonstration. I think this demonstrates quite nicely the kind of technologies that we're interested in at ZP. This is a off-the-shelf glucose strip. It's not a ZP glucose strip. But it's the kind of technology that we're very interested in as well. This is a ZP technology. This is a sort of generic glucose strip. This is a glucose meter. Sorry, this is a ZP meter. You'll see in a minute that this meter is actually multi-analyte. When I mean my multi-analyte, you'll see me use these series of QR codes, and I can actually go between different analytes by using different sensors and different QR codes. With that said, let me go on to why I'm talking about glucose meters. I think glucose meters actually demonstrate really well the kind of core science that we like at Zimmer and Peacock, which happens to be electrochemical biosensors. They just demonstrate so much, really, that in fact, you know, you can sorry, I just had to prick my finger there to get some blood out of that. They do demonstrate some of the things we really like about electrochemistry. From a commercial perspective, it's fairly low cost to manufacture these kind of strips. The electronics are small, low power, and they're also, there we are, my glucose reading in this particular case had food a couple of hours ago, so I'm about 112 milligrams per deciliter. Typical glucose is 90 mg per dl, but coming down off for a meal, that's fairly okay. So I just wanted to bring that up because it sort of demonstrates that, you know, people are very interested in these connected health ecosystems, and a lot of this they think will start at home. And if this technology, or if these kind of ecosystems do start at home for remote monitoring, then I really think that, you know, and I am biased, you know, that electrochemistry is actually going to be the technology to do this. Why? Well, people have been doing this kind of at-home testing using electrochemical sensors for a good 40 years at this point. Low cost, works with very clean, very complex samples, like, you know, a drop of blood is quite a complex sample. The reading was actually quite fast. The only thing that's often lacking, actually, you know, is actually the kind of IoT part. Each glucose strip manufacturer now is kind of inventing their own IoT, let's say, infrastructure. But the problem is with all of this, they're all very closed. There's not this kind of open infrastructure where everything is talking to everything else. And maybe that'll be a sort of theme that I want to kind of emphasize today. Now, this is just a quick experiment for you. If you're following this video, if you're on an Android phone, please scan this QR code. And if you're on a Apple phone, iOS phone, please scan this QR code. What that will have just done is it'll have installed an app on your phone. And from that app, I'll maybe give you a demonstration from my phone. You'll actually be able to scan a series of QR codes. So, for example, if I just, there's a chili QR code here, there's a ginger QR code here, there's a pH QR code here, there's a nitrate one, total antioxidative capacity, glucose, potassium. This one, scan this QR code. I'm not going to say what it is because I'd rather you scanned it whilst watching this video to find out what that's about. And then there's a couple here for my sort of developer friends. There's something called amperometry and open circuit potential. But let me just go to here and just say, I've got my phone here. What I'm going to do now is, when I do this, it's basically looking for a QR code here. So if I just go up to here, it's just gone over to potassium. If I go over to here, it's just gone over to glucose. If I go over, if I just go over to here, it's gone to glucose still. It's gone to total antioxidative status. So I keep changing the target of this app by using different QR codes. I did mention this, but actually this device is in Bluetooth connection with this smart device. So that means every time I scan a QR code, I'm going to be able to change the target for that meter. So let me just go over to here and just do this. There we are. Right. So what have I just talking about here? So I'm talking about connected healthcare ecosystems, but I actually think there's going to be a bit of a gap in this market, and actually that's that there's really no biosensors around. You've got startups and you've got big companies talking about it, and you've got companies that sort of do it, but the companies that are sort of doing it, they're very closed ecosystems, and I think some of the larger kind of companies are possibly too much inertia within those businesses to really take this on. So I think it will be startups that sort of break ground on this kind of technology. Let me just go back to my screen for a second and just say the platform that I kind of have in front of me. And when I say platform in front of me, for example, what I mean by that is I've got some hardware here, I've got a sensor here, I've got an app here, I've got a sort of generic sample here, and I'm just going to do a quick test in a minute. But what you'll actually see happen is I have some hardware in front of me. This hardware allows us to use different QR codes, and every time we scan a QR code, it changes what the app is actually able to do. When the app knows what to do, the app will tell the device what to do by Bluetooth. For every, let's say, target, in this case that was pH, you'll need a pH sensor. If the app scans QR, a QR code for nitrate, you'll need a nitrate sensor. If it's total antioxidant capacity, you'll need a TAC sensor. If it's glucose, you'll need a glucose sensor. But you can see that the QR code keeps changing the target analyte, and we do need to change the sensor every time, but this has got one hell of a versatility. Now this is the bit where it starts to actually be able to plug into the kind of health ecosystems that we kind of see, or starting to emerge, which is when the app has done the assay, it's actually going to send the data to the cloud. So bang, now you're starting to get into this kind of ecosystem, because actually we will, you'll see me do it, give a result here and there on the here and now rather on the phone, but you'll also see that there's actually a cloud connectivity, that the data also went up to the cloud as well. And actually in different spaces, for example, my customers are actually sharing that data with us through the cloud because they want some advice on a particular aspect. Now that's not the same in the healthcare system. You'll have healthcare professionals doing that, but it's just to say that the workflow and technology stack is essentially in place, and we also have an API built in place as well. So what I might do at this point is go to my external. I'm just going to take a generic sample. I'm going to put it on the sensor. This is another aspect about the kind of science that we like to do at Zimmer and Peacock. It's really only the size of a drop of blood. Many analytical systems require a bit more sample, but the beautiful thing about what the kind of science that we do is actually doesn't require a lot of sample. I'm just giving the sample a name there, and I'll go to assay, I'll start the measurement, and it's on its merry way. Now this piece of hardware is really what we describe as an OEM, or an original equipment manufacturing solution. It's intended to get other people to the market with their ideas. The fact that I have all these QR codes here, that means I can keep changing the app. And I do want you to watch the video later on and scan. There's something called yours on one of the slides. Scan that and see what that does. Because what it is actually trying to do is demonstrate to you that actually it's not ZP that's going to market with this technology. We may be quietly in the background, but actually we expect you to go to market, and we're trying to enable entrepreneurs, companies to have an idea which requires a biosensor. They want to have a sort of cloud connectivity because they want to plug into the kind of healthcare ecosystems, and all of that is built in. Now I've got a result on my phone, and what I want to do as well is I'm just going to have a quick look online. Just doing some quick refreshing, because I also said that the technology also is cloud enabled as well. So I'm just going to share my screen for a second. Here it is. So this is the result I just got. I'm not expecting doctors and nurses to be looking at raw signal, but it is important if you're making one of these kind of remote systems. How can you do quality control on it unless you can actually sometimes see the raw signal? So even though I got a result on my phone, actually the signal that gave me that result is also saved as well. So if I was the doctor or the nurse, I could see my micromolar number here, and I also see the raw signal that's got behind it. So if I was to summarize it, ZP, sure, we see, we're really excited by the idea that there's going to be these kind of healthcare ecosystems, with people being remotely monitored and remotely looking after their health, and getting results on smart devices. And so we want to really enable that, and that's what this technology stack, which I haven't actually named, it's called SenseItAll, is intended to do, whether it's in the wearable format or whether it's in this IVD, in vitro diagnostic format. The whole intention is to get people to market, I just say as quickly as possible. But we also understand that actually, you get the results on the phone, but we also send the results to the cloud as well. Something I should have actually mentioned as well, and I will just mention it while I'm here, is it does have an API built into it as well. So, this kind of whole cloud connectivity and talking to other people's systems is inherently built into the technology platform as well. And I think the word platform is, is accurately used in this particular case. So if you've got any questions of ZP, don't hesitate to reach out to us. Otherwise, have a good evening and maybe speak to some of you soon. Okay, thanks very much.